Hi, in this presentation, it is about the solution of data encryption based on TCP transparent. This solution requiring not changing the existing topology and the application based on the existing data transmission method and make the data encrypted when in TCP transparent. This presentation included topology introduction, and we will have demo. Here we use VPN solution. So it have the explanation of how to set up server, how to configure the R1500, and final we will have a test. First of all, let's have a brief view of the topology. The application scenario is meter reading. There have many R1500 installed in field. Suppose they installed a local 1, local 2, local 3, or more. They have two RS2320 ports of R1500 connected to meters separately with serial port COM1 and COM2. R1500 as a TCP server. The server port is defined as COM1 with 82 and 21, COM2 with 82 and 31. In this case, in center side, it will be a TCP client connect to R1500 with the port 8221 and 8231. They connect in TCP transparent mode. TCP transparent connection established so that center and the meter can communicate with each other. As you know, TCP transparent transmit data in plain text. There are requiring data encryption when data transmitting in the network. In the meanwhile, it is required to remain the existing TCP transparent mode. You have several ways of transmitting data in security, like MQTTS, HTTPS. The S stands for security. This protocol uses TLS to enable secure transport layer, but MQTT and HTTP will change the way of TCP transparent. Their working way is totally different from TCP transparent. It will not working like in this way. So they are not capable. VPN would be the proper solution which is able to encrypt data based on TCP transparent. On center side, it could be a center router that able to run VPN server mode. In this demo, I'm going to use a Linux system to run OpenVPN server. For server configuration, how to configure OpenVPN server? In the first place, we need to choose a suitable authentication for your application scenario. If you log in the R1500, they have the settings about. Here we use R1500 for demo. And for the OpenVPN setting, as you can see, for the authentication tab, they have several authentication method like an pre-shared key, password, X509 for authentication. If we use X509, it will be a massive work for generating the certification because they have massive quantity of VPN clients. So in order to make the deployment as simple as possible, we choose password for authentication. Even we choose password for authentication, OpenVPN still requires CA. Even OpenVPN still requires CA, requires this file, this X509 CA need to be imported to the VPN client. So a second step, they need to generate certification. I've already made one for this demo. We won't demonstrate in detail here. You can refer this application note. OpenVPN client with X509 certificates, and it shows how to generate the certifications. Next step, let's check the server setting. I have already installed OpenVPN in this host. Let's check the server setting. Here is the server setting. The main setting would be local IP. You should define the local IP of the OpenVPN server. This is the IP of the OpenVPN server, and this is the local host IP. So okay, of course it should be the mode server because this host run as OpenVPN server, and the server port 1194. Here we use UDP for demo. UDP is faster than TCP. The virtual IP port is also defined by the server. These are the certification paths. Please put the X509 files in the corresponding path that server can use. This is the data encryption algorithm. Here we use AES 256. These commands are especially for password authentication. Script security 3 means save the password in the system environment. Save the password in the system environment variables. These commands are used for authenticate the VPN client with username and a password. This is the script for checking the users. Since only use password for authentication, so not requiring certification, we use this command. OpenVPN can assign static virtual IP according to common name. Username as common name means we can assign static IP address based on username. The static virtual IP can be predefined. You can set which username use which IP. The static IP configuration stored in this path. Number 4, how to use script to generate password for VPN client embed on server. Since they have massive quantity of VPN clients, create username and password for each client one by one would be difficult task. No worries. Script can help us quickly generate username and password. I've already made a script named as create user.sh. This script is to generate users in batch. This is the script. This is the username. Like in the topology, we name the FD100 with a local username with a local 1, local 2. So when we generate the username, we define local here and the password. And the username and password will be exported to this file, PSW file. Input the command /2 execute the script to generate the users. The users has been exported to this file. As you can see, they have generated a lot of users. The format is local 1, password, pass1. The next step, how to assign static virtual IP for R1500. This is to bind the virtual IP for these users. In this step, we also use script to generate the static virtual IP assignment to bind this static IP with these users. Go to the CCD folder. I've already created the CCD folder. And I also have created the script to generate the static IP setting. This is how the script looks like. This is the IP address, and Of course, the local name should be corresponding to the username. This is the file name, and this is the command for assigning the static IP. The command is ifconfig horizontal bar push, and then the IP address subnet dot slash ccd client.sh to execute the script. As you can see, they have created 10 configuration for binding the static IP for the users. Okay, on server side, the setting is completely. Let's configure the VPN client. On VPN client setting, just set the parameters match with the server. R1500 as a VPN client. The protocol server use UDP, so VPN client should select the UDP. Server address is 192.168.0.74. The port is 1194. Interface type is still no. Password use password. Authentication type used password. Okay, here's the username and the password we need to configure. As we already generate a lot of users, choose one users to configure. For example, I use local 7. The password is PASS7. Encrypt algorithm is, as we mentioned on the server setting, it is AES 256 here. These settings remains default. We have defined the fragment here on the server. So on VPN client, we should also configure this command. And please also import the CA file. Save the setting. VPN client is done, and let's check the status. Okay. Forgot to start the VPN server. First, we need to disable the firewall. Okay, firewall has been disabled. Start the VPN server. Okay, it is connected. Let's check if they can communicate with each other. Server virtual IP is 0.1. It is accessible. And on server side, in center also is also reachable, also can reach the VPN client. And the point is, as you can see, the VPN client, we use local 7. On the server side, we have defined the static IP for the local 7. As you can see, 10 at the 0 to 7 is responding to local 7. Let's try another user. For example, local 9. The local 9 static IP is 10 at the 0.9. Let's try if the VPN client can get the static IP. Local 9 password is PASS9. Okay, connected. And the VPN get the static IP accordingly. Last is about the test. See if we use virtual IP can make the data encrypted. Set the TCP transport. When we use VPN solution, we still can use TCP transparent, so that no need to change the topology of the, no need to change existing topology. And the serial port setting is need to match with the meter. Application mode is transparent. Protocol is TCP server. Local IP you can leave it blank, so that you can connect to RFD100 with physical IP, and also you can use virtual IP to connect to RFD100. The port we define is 82 and 21. Save the setting. Okay, now we need to connect a meter simulator. We use a serial Tor to simulate meter. The meter is connected in this COM port. Connect the meter. And in center, in the first test data transmission with physical link. Okay, we use the physical IP. In center side, we use physical connect to the R5000 with the physical IP. The IP of the R5000 and the port corresponding port is 8221. Connect to the R1500. In the meanwhile, I will capture data for analyze. Okay, let's try to send data. Meter send data to center, and in center side we also send some data to meter. Okay, data transparent with no problem. Let's check the data if I'm use Wireshark to check the data, to analyze the data packet, delete the IP. This is the data that we just sent. When they change the data, it is in hex format. As you can see, this is the data sent from center side. As you can see, it can be converted to the ASCII, and as expected, the data is not encrypted when you use a physical link to connect to R300. Now let's use virtual IBC if the data encrypted. The virtual IP of the client is the virtual IP of R300 is 10.0.9. When you use when you use virtual IP, also can connect to the R300. That's because we set it to blank. So you can use both physical IP and the virtual IP and connect to R300. In the meanwhile, capture the data. Meter data sent to center. Center receive the data, and the center side send data to meter. Okay, receive it. Transmission without problem. Okay, let's check the data. As you can see, all these data transmit in security. The data has been encrypted. All these data are encrypted. Data is encrypted. Okay, that is all for this presentation. The point is, the important point is when you use VPN solution, please use virtual IP to connect to the R1500. So the data will be transmitted in the terminal and the data will be encrypted. Okay, thank you. Hope it is helpful. Bye.